Hi everybody, this is Ryan, and today we're going to talk a little bit about geometry. So let's get started. So geometry is the study of shapes and their properties. In geometry, we use points, lines, segments, and rays to describe different things. So here are those key points. So we have a point, and a point is a location in space with no length, width, or height. So we need to remember that. A point is a location in space with no length, width, or height. It's just a dot. And we label that with a capital A. A line segment is the infinite portion of a line with two endpoints. So a line segment is a finite portion of a line with two endpoints. So a line would look like this. A line segment is made up of 2 points, A and B, and we would label that as line segment A, B. Now, if you have a line, between a segment and a line looks like this. And it would be labeled AB, but it would have an arrow on top like that. So that's a line. A line is an infinite collection of points extending infinitely in both directions. That's what a line is. It is labeled AB like this. An array is a part of a line that starts at an endpoint and extends infinitely in one direction. So a line or array would look like this. Here's point A. A ray would go in one direction. So you would call this ray AB. And typically the part that doesn't have an arrow on the end is the starting point. Notice how that's A. Parallel perpendicular lines. Parallel lines are lines that lie in the same plane and move in the same direction but never intersect. So parallel lines look like this. Two lines intersect at a right angle are called perpendicular lines. So if this line and this line, they intersect, and this is a right angle right there, 90 degrees, then the line will be perpendicular. The distance between parallel lines remains constant as the lines extend infinitely in both directions. Planes. A plane is a two-dimensional surface with finite length and width, but no thickness. So a plane would look like this. Usually you label a plane with a script letter, like capital A or capital B. Properties of a plane. 3 points include at least one non-collinear point. So if I have a plane, we would call this plane A, B, C. So this is called plane A, B, C. Notice how there's 3 points, and they're non-collinear, which means they're not on the same line. So collinear means they're on the same line. Non-collinear means not on the same line. A point, a line, and a point not in the same plane determine a plane. The intersection of two distinct planes is a straight line. An angle is formed when two line segments or rays meet at a common endpoint called the vertex. So here's an angle. This is A, B, C. So this is called angle A, B, C, and B is the vertex. Angles are measured in degrees or radians. Measuring angles involves using a tool called a protractor. To measure an angle, place the protractor on the vertex of the angle and align the straight edge with one side and read the degree value where the other line intersects the protractors. And you might have to extend your line. Extend the line so you can read it on the protractor. So there's several types of angles. There's a right angle, this is a right angle, 90 degrees. You have an acute angle, which is smaller than 90. You have an obtuse angle, which is greater than 90. The straight angle equals 180 degrees. And a reflex angle is the other side of the angle. So if we know this angle is, say 80 degrees, the reflex is the other side. It's this part down here. Degrees versus radians. Degrees are the most common measure of an angle. A circle is divided into 360 degrees. Radians are an alternative unit of angle measure. A circle In this circle, there are 2 pi radians. So 2 pi radians is the same as 360 degrees. It's one complete revolution around the midpoint. So to convert angles degrees to radians, you use this formula. To convert radians to degrees, use the other formula. Degrees are commonly used in everyday situations like navigation and construction, while radians are used in advanced mathematics and scientific fields. So let's convert 45 degrees to radians. So we're going to go from angle degrees to radians. So we have angle degrees, so we're going to go 45 times pi over 180. So if you reduce that fraction, 45 goes into 180 how many times? So this would reduce 4 times, so you'd have pi over 4 radians. Now let's convert pi over 3 radians to degrees. So this time we'll use angle degrees equals radians, so it would be pi over 3 times 180 over pi. Now notice this time your pi's cancel. 3 goes into 180 60 times, so that would be 60 degrees. Okay, supplementary and complementary angles. The measure of an angle is a numerical value that represents the amount of rotation or separation between 2 lines or line segments. It qualifies the size of the angle. We use the abbreviation M for the measure of the angle. The measure of angle A is written the measure of angle A. That little M right there means measure. Supplementary angles add up to 180. They add up to 180. Complementary add up to 90. Vertical angles. So when you think about 2 lines that intersect, this one and this one. Vertical angles are a pair of opposite angles that are formed when 2 lines intersect. So if I just name, you can also label angles with numbers. If this is 1 and this is 2, we would say angle 1 and angle 2 are vertical angles. And the thing is about these, what's neat is they are equal. Vertical angles are equal to each other. A transversal is a line that intersects 2 or more parallel lines. It cuts across lines to form different points, creating various angles. So if I have a line, let's call this line M. We can also label lines with letters. And I have line N. And I have another transversal here. Whoops. That was interesting. And I have a transversal here. Let's call that transversal just L. M and N are parallel. And the way you can note parallel is little triangles on the lines. So we would say M is parallel to N, and they're cut by transversal L. So we would form some angles. And typically the way we would number these is I would number them as 1, 2, 3, 4, 5, 6, 7, 8. All those different angles. So we would say alternate interior angles are a pair of angles that lie on opposite sides of the transversal and are on the inside of the 2 lines. These angles are equal in measure. So alternate interior would be like 4 and 6. There's other ones. There's like 3 and 5 also. So 4 and 6, 3 and 5. All the exterior are the same except for they're on the outside. That'd be like 1 and 7 and 2 and 8. Corresponding are pairs of angles that are on the same side, but one's on the inside, one's on the outside. So corresponding would be like angle 2 and angle 6. And there's actually 4 of those. And angle 3 and 7. In each one of these cases, these are all equal. Every one of these are equal. Whether corresponding, alternate interior, alternate exterior, they're all equal in measure with its corresponding pair. In geometry, triangles are one of the fundamental shapes. They can be classified based on their angle measure and side length. Okay, equilateral triangles an equilateral triangle has all 3 sides of equal length. Consequently, all three angles are also the same length. So if I have an equilateral triangle, we would mark that like this. We would call this triangle A, B, C. So a triangle A, B, C, and each side is the same length. So AB equals BC equals CA. They're all equal. And all the angles are also equal. Angle A equals angle B equals angle C. Isosceles is an isosceles triangle has two sides that are equal. So in an isosceles triangle, we would have two sides that are equal, like this side and that side. The scalene would be no side that are equal. That'd be just an odd one, like something like this. Be something like, say, we have this. That triangle, no sides are equal. And then we can go through and do a right triangle. A right triangle would have a right angle. An acute triangle has all angles less than 90. An obtuse triangle has one angle more than 90. So this would be a 90-degree angle. This would be all less than 90. Oops. All less than 90. And this would be 1 greater than 90. So here's your type of triangles. Here's equilateral. And notice those hash marks. The hash marks mean equal. So you have equilateral, isosceles, and scalene. Then you have acute, right, and obtuse. Now whenever you have a triangle, let's say we have a triangle here, A, B, C, the sum of the angles is always equal to 180 degrees. The sum of the angles of a triangle are always equal to 180 degrees. So let's try it here. So if I try a triangle, if one angle measures 45 and the other angle is 30, what's the third angle? So if I have a triangle, one's 45, one's 30, and we're looking for the third one, how are we going to find the third angle? Well, we know they add up to 180 degrees. So 45 plus 30 plus x equals 180. So you solve that. 45 plus 30 is 75. Subtract 75. So x equals 105. In a right triangle, if one angle is 90 and the other is 35, what's the third angle? So this time we have one angle is 90, and there's 35, and we have x. Now in this case, we know that one's 90, so we could go 90 plus x plus 35 equals 180. So 90 plus 35 minus 180, that would be 55. Similar triangles are figures that have the same shape but different sizes. They are like scale model each other. If two triangles are similar, then their corresponding angles are equal and their sides and their corresponding side lengths are in the same ratio. The Pythagorean theorem is a good tool to find side length, but it has to be a right angle. So C is your hypotenuse, A and B. So when you use the Pythagorean theorem, you got to remember, C is always the hypotenuse. So if I have a triangle, and it's a 3, 4, 5 right triangle, and I want to find my x, I'm going to go 3 squared plus 4 squared equals equals c squared. That's going to be 9 plus 25 equals c squared. 9 plus 16 equals c squared. So 25 equals c squared, so 5 equals c. So we would call that a 3, 4, 5 triangle. Let's talk about area and circumference. So, properties of rectangles. Rectangles have 4 sides and 4 right angles. So this is a rectangle. The big thing about a rectangle is opposite sides are equal. Remember the hash marks? They mean equal. The perimeter, if this side is the length and this is the width, the perimeter is equal to 2 length plus 2 width. The area is equal to length times width. The rectangular garden of a park is 15 meters and 8 meters. What's the area and perimeter? So the area would be equal to 15 times 8, or 120 meters squared. The perimeter would be equal to 2 times 15 plus 2 times 8, or 30 plus 16, or 46 meters. Make sure you label your answers. Always label your answers. Triangles have 3 sides. The sum of the triangles of the angles is 180. The perimeter of a triangle, if I have a side A, B, and C, the perimeter is A plus B plus C. The area is always 1/2 base times the height. So this time we have a roof that's a base of 12 and a height of 8. We're going to say that the area equals 1/2 of 8 times 12, or 4 times 12, or 48 meters squared. So this time I have a triangle with so 2 sides of the triangle are 13 and the other is 15. Calculate the perimeter, you add them up. 13 plus 13 plus 15. That'd be 26 plus 15. 26 plus 15, or if you said triangle with 13 and 15, calculate the perimeter of the roof. So 13, if 2 sides of the triangle are 13 and 15, calculate the perimeter of the roof. So it's 13 plus 13 plus 15 equals 41, which is in here. So I think it's going to be 41 is our answer, 41 meters. Trapezoids look like this. The thing about trapezoids is that this side and this side are always parallel. The bases are parallel. This is base 1. This is base 2. Usually they call that a big B and a little b. This is little b and this is big B. So the area is 1/2 the height, which is right in here, times the little base plus the big base. So a cross section of a dam looks like a trapezoid. The height is 10. The bases are 20 and 30. So the area is equal to 1/2 of 10 times 20 plus 30. It'll be 5 times 50, or 250 meters squared. Circles. We know about circles. The diameter is twice the radius. The circumference is 2 pi r, and the area is pi r squared. So a circle has a diameter of 14. It means the radius equals 7. So the area would be area equals pi times 7 squared, or 49 pi. Remember, pi is equal to 3.14. So 49 times 3.14 would equal 153.86, or 154. The circumference is 2 pi r, so that would be 2 times pi times my radius, which is 7. That'd be 14 pi. 14 times pi is 43.96, or 44 centimeters. So now to find the area of a regular shape, we're going to break a regular shape down into smaller shapes to be calculated. Calculate each shape and add them up so you can find the volume to find the area. Now, properties of regular rectangular solids. So volume is length times width times height, and surface area is 2 times the area of this side, area, and area. A rectangular solid has a length of 8 a width of 5, and a height of 3. What's the volume? So volume equals 8 times 5 times 3. So 8 times 5 times 3 will be 120 meters cubed. The surface area would be equal to 2 times 8 times 5 plus 5 times 3 plus 8 times 3. That would be 2 times 40 plus 15 plus 24. 40 plus 15 plus 24 equals 134. So 2 times 134 would be 268 meters squared. Cubes. Cubes are special prisms or special solids that all the sides are the same length. So it would look something like this. So all the sides are the same length. You can actually draw that. Looks like this. Well, I've lost my pen. So volume is equal to side cubed. So to find the volume of a cube, you take 6 times 6 times 6. So volume equals 6 times 6 times 6. So 6 times 6 times 6 equals 6 times 6 times 6 equals 2 equals 6 times 6 times 6 equals 216 cubic meters. So spheres are like cubes. They're a circle that's kind of like a ball. We have cylinders. The volume of a cylinder is volume equals pi r squared h. Surface area is the area of the base times the height. And we have cones. Here's the volume of a cone. So I hope you enjoyed this video. Sorry my pen went out on me, so I couldn't draw anymore. One thing I do recommend is that you go through and you remember these formulas and try them out. So